What is artificial intelligence?
Artificial intelligence is a branch of computer science that enables machines to reason and solve problems like humans or even better. Traditionally, machines are good at repetitive tasks dictated to them through programs. With AI, machines can respond to inputs they were not previously programmed for. This behavior is made possible by exposing machines to vast amounts of data and algorithms that build models from that data. These models can then respond to new and previously unseen data.
What are the differences between AI and machine learning?
Artificial intelligence is a broad concept aimed at creating machines that learn, think, and solve problems like humans. Machine learning is a specific method to solve a problem by making machines learn from historical data. AI generally requires several ML systems to function. An AI-enabled machine can even create a new ML program on the fly to cater to new types of inputs in the future. ML is one of the tools that AI can use.
What are the different types of machine learning?
There are 4 broad types of machine learning, which are supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning.
Describe supervised learning.
In supervised learning, machines are trained on structured data sets containing labeled inputs and labeled outputs. For example, one could feed a machine thousands of images of birds and cats, each labeled as either a bird or a cat. When the machine is queried with a previously unseen photo of a cat or bird, it will be able to respond correctly using a prediction algorithm.
Describe unsupervised learning.
In unsupervised learning, machines are trained on raw datasets that are neither structured nor labeled. The decision to create associations among the data lies with the machines assisted by algorithms. This type of learning is often used to group similar data. For example, one application is customer segmentation for marketing purposes. In short, raw data is grouped into meaningful segments.
Describe semi-supervised learning.
Machines are trained on a combination of mostly unlabeled data along with some labeled data. By learning patterns from the labeled data, machines group the raw, unlabeled data into clusters and associate labels with these clusters. This process converts raw data into manageable, labeled data. In the next phase, the learning becomes supervised, with the machine assigning labels to the remaining data. In short, machines label the data themselves and continue to learn.
Describe reinforcement learning.
Reinforcement learning is a type of trial and error learning where a machine continuously gathers data. For example, autonomous systems like self-driving cars collect data and feed it into a centralized system. This system constantly improves itself to drive more efficiently and prevent accidents in the future. Each time the system makes a decision, a reward or a penalty is assigned based on the outcome. In the future, when a similar situation arises, the machine will choose the decision with the highest reward. The entire process is a form of feedback-based learning and correction.
What are the 2 common fitting issues in machine learning models?
The 2 common fitting issues in machine learning are underfitting and overfitting.
Briefly explain the underfitting problem in machine learning.
When a model is too simplistic to predict large variations, the problem is called underfitting. Too little training data or an overly simple algorithm will result in a simple model. For example, consider a linear, straight line model trying to predict nonlinear outcomes that are not in a straight line. In this case, the model's predictions will be inaccurate because it cannot capture the variations in the data.
Briefly explain the overfitting problem in machine learning.
The opposite of underfitting is overfitting. A model turns overfitting when it becomes too complex and considers even outliers and noise as data. Imagine a model that is a line which fits almost every input data point. For any input from the training data, this line will predict the outcome with accuracy. However, with unseen new data, this model tends to produce large inaccuracies.
What are the 2 broad types of data sets based on class distribution?
The 2 broad types of data sets based on class distribution are balanced and imbalanced datasets.
What is an imbalanced dataset in ML?
The quality of ML models depends on the quality of the data. A dataset is considered balanced if there is a similar number of samples from all the classes or groups. For example, consider a dataset with two classes, cats and birds. Let the dataset contain 10,000 photos of animals belonging to either class. If there are 9,000 photos of cats and only 1,000 photos of birds, the dataset is considered imbalanced. The data is skewed towards cats.
Why is an imbalanced dataset a problem?
An imbalanced dataset often causes ML models to perform poorly on minority classes. For example, consider a dataset of credit card transactions. Fraudulent transactions are usually underrepresented because they occur far less frequently than genuine transactions. If this imbalanced data is used for training, the resulting model may struggle to accurately predict the fraudulent transactions. This behavior will undermine the purpose of the model.
Can you tell me a few common approaches to balance an imbalanced dataset?
There are several techniques to balance an imbalanced dataset. One approach is undersampling the majority class, but this requires ensuring there is enough data when combining the minority class with the undersampled majority class. Another approach is oversampling the minority class by collecting more data for that class while pausing data collection for the majority class.
What is the bias variance trade-off?
Bias refers to the prediction errors from an underfitting and overly simple model. Variance refers to the prediction errors from an overfitting and complex model. Any attempt to decrease bias increases variance and vice versa. The goal is to find an optimal point where the model achieves a balanced prediction with minimal errors in both bias and variance. This balance is called the bias variance trade-off.